Yeah, can you see my screen now?
Yes, sir.
Okay, now let's try to understand this part, Tanisha. So you have drawn this figure. Now, yeah. So basically we need to prove the formula cos A plus B, that is cos A cos B minus sin A sin B, correct?
Yeah.
Now in this case, so you have drawn the unit circle now. This is the point P1. Let's understand the point P1 here, okay? So this is the point P1 which you have made it here. This is the P1. This point is P1 here, okay? So basically this is the initial side from here. You rotate it in the anti-clockwise direction. That's why this angle is X, correct?
Yeah.
This angle is X. From here, you went to the P2 part. This point is P2, correct? This point is P2. What is the angle here? This angle is Y. So totally, this total angle will be equal to how much? X plus Y?
Yes, sir. X plus Y.
Excellent, correct?
Yeah.
Now, so from the initial side, now from here, this side, we took this to the anti-clockwise, to the clockwise direction. We go here till the point P3 here. This point is P3, fine?
Okay.
This point is P3, fine? Now, and what will be this angle? This angle is same as this angle, Y.
Yeah.
So this angle becomes in the clockwise direction, so that's why negative sign, correct?
Yeah.
Minus Y. And this is positive. Clear? This part is clear. So we have, so what we have done is, now we joined the P1 to P3 and P4, this is P4 to P2, correct?
Yes, sir.
Now, clear this part? Understood this part? Now, what is the coordinate now? So here the coordinate is, since your unit circle, on the x-axis the coordinate is, basically this is sine 0, this is x-axis is the cost value, cos angle, cos 0 is 1 and sine 0 is 0. So basically 1 comma 0 is the coordinate. Now what will be the coordinate here? X-axis, whatever the angle it is there, that will be cos x, and vertical axis, vertical is nothing but the sin x, correct?
Yes, sir.
So this coordinate is cos x comma sin x, right? So here at this point P2, the angle is x plus y. So the x coordinate will be cos x plus y and y coordinate will be sin x plus y, isn't it?
Yeah.
Correct? Because when you come here, it becomes the minus 1 comma 0. This coordinate is minus 1 comma 0, isn't it?
Yes, sir. Yeah.
Right. Okay, next. Similarly here we went in the clockwise direction, so angle was minus y, so the x component, x axis will be, x coordinate will be cos of minus y and y coordinate will be sine of negative y. Okay. Correct?
Yeah.
Any questions, any doubts in the understanding the part?
So we got minus 1 comma 0 by in terms of the Cartesian plane.
Yeah,
right?
in terms of Cartesian coordinate, correct.
Okay.
Here's the unit circle. Basically radius is 1 unit only. This radius is 1 unit, right?
Yeah.
So here it will be, this coordinate will be 0 comma 1, correct? No?
Yeah. Okay.
And this coordinate will be minus 1 comma
minus
0.
1 comma 0. Yeah.
It's nothing but the sine, cos. First x coordinate is always the cos angle and the y coordinate is always the sine angle,
Sine.
right?
Okay, sir. Got it.
Now we just need to prove the congruency between these two triangles. So let's consider this triangle, okay?
Okay.
This is a triangle you see here from O, P1 and P3. O, P1, P3, okay? And the triangle, this triangle. P4, O, P3. Sorry, P2, right?
Yeah.
O, P2 and P3. These two triangles we need to prove the congruency. Correct?
Yes, sir.
So if you just see the congruency, what is the congruency? See, this is radius. This is radius, same as radius, clear?
Yeah.
Understood this part?
Yes, I understood.
Correct. Okay, excellent. Okay, clear. Now this part is clear to you. Now see, these are radius. All these are radius. Can you see that?
Yes, sir.
So this becomes this angle. This side will be same as this side. This triangle. This side will be same as this side. And whatever angle, this angle is y, correct? And this angle is here. This part, right? So assume this angle is, let's say, if this angle is, let's say, z.
Okay.
So this angle P1 O P4 will be y plus z,
Yes, sir.
and same angle P4 O and P2 will be, again, this minus y is the negative sign for the angle, but the total angle will be y plus z only here.
Yeah.
Correct? If you see from this side, so minus z also, so it becomes the same. So these two triangles are congruent by SAS. So can I say that triangle OP1 and P3 is congruent to triangle OP4 P2? Correct? These two triangles are congruent.
Yeah.
Then that means I can say P1 P3 will be equal to P2 P4 CPCD.
Okay.
Correct?
Yeah.
Now same thing, you can square on both the sides. So this becomes the square here, same as you can square it here. Correct?
Yeah.
Now you can just apply the distance formula and then prove it. It will be same. Correct? So distance formula is P1 P3. So P1 is here, P3 is here. So you remember the distance formula, right? X1 minus x2 whole square plus y1 minus y2 whole square should be equal to this. Should be equal to P4 P2. So 1 minus again x1 minus x2 whole square. So cos x plus y minus 1 whole square, and then sin x plus y minus 0 whole square, like that.
Yeah.
Got it?
Yeah.
Clear this part? Any questions, any doubts?
No, sir.
Now just write down this part, Anushya. See, P1 P3 square, use the distance formula,
Okay.
and use the P1 P4 whole square, use the distance formula.
Okay.
Got it? And then we'll equate both the things.
Okay.
Okay? Try it out. Done? This will be easy for you. Okay?
Yes, sir. I'll try the first one.